Hey everyone, we're going to be doing another video here on the Astrodynamics of this mission and actually getting to use SDK to start simulating stuff. To start, I'm basing this not on the time period when we're doing the mission, it's for you guys to figure out, but going off of an example that exists, we'll be talking about how the most recent Mars rover from NASA got from its Earth orbit to Mars. Time place this took place between is end of July 2020, and it got there on February 2021. As we talked about last time, there are a certain number of windows every couple of years when it's possible to go from Earth to Mars without using crazy amounts of delta V. You can go whenever you want, but besides those windows, it's impossible with current rockets to get there. 203 days is how long it took to coast from one to the other. And a tool you guys can use when you do your actual mission is called the pork chop plot. The pork chop plot is used by engineers and scientists working on these kind of missions to denote how much energy is going to be expended between different times. See here, I have it between 2015 and 2021, going from Earth to Mars. The y-axis here is how long your flight's going to take. The x-axis is when you leave. And the closer to light blue, the cooler of a color you have, the less delta V you're going to expend. So you notice looking at both the arrival delta V and departure delta V, time that Mars 2020 left is in a pretty good big window. You can see with that window that was also when a number of other Mars orbiters were launched as well, one from China and one from the UAE. So moving on to SDK now, if you can download the license file that Dr. Dong gave us this past week and make sure you're connected through the UF VPN if you're not on campus, called Cisco AnyConnecting Google UF VPN. Get more information on it. So we'll be doing a scenario here emulating that mission, which took place from, what was it again? Summer of 2020. And got to spring of 21. Okay, so to start, I'm going to go over configuring the window. There's a billion different ways you can do this, but this is the way I like it for this kind of thing. Click View, new 3D graphics window, View, new 3D graphics window. So we have one in the Earth fixed axis. Have this one on Mars. And we'll have this one set up for the sun. For the sun one, you're going to also make a change that you can see things from really far out. So 1 to the 13th kilometers for our scale here. Now we're going to add our planets as planet objects. We're going to have the Earth. And we're going to have Mars. If you could set the ephemeris source to D430 on those as well. Also, if you don't have this central body thing in the bottom there, do edit preferences and you see where I had that. You do that actually by view and enabling planetary options. Just keep that on. Over 2 planets, we need our satellite. Our satellite's actually going to be around Earth. And we're going to be using AstroGator. It's on Keplerian. Doesn't really matter. This will all get overwritten. Just make sure that the epoch is right. Yep. Our satellite around Earth. And also for the satellite, so you can see it in the sun window, to do 3D graphics, model, and just set these all the way up. Now, even from the sun, you can see it. And for some reason, whenever I do this, I have Earth and Mars also showing up as in the center of the sun. Just ignore that. I have no idea what that is. Next, we're going to go into utilities, component browser, design tools. And the way this will be working is by using a Lambert solver. The Lambert solver is just a way of solving a problem, kind of like Kepler's equation, that is converged upon, not solved analytically. And that numerical solution allows you to go from one kind of an orbit to another in the optimal way. I'm going to make a duplicate of that. I'll add Earth to Mars. And we're going to edit that. Central body, all of this revolves around the sun. It left on July 30th, 2020. And it took 203 days. We're going to set this to initial and final central bodies. It's going to go from an Earth orbit, considering departure body's gravity, and it's going to go to Mars. And I made a mistake there. What you're actually going to want to do is have the sun point mass for propagator for the whole orbit. And you're going to want to throw your new thing in there. Set this to run active profiles. Converge on a solution. And you can see that on July 30th, my step's really small. Right, so on July 30th, takes off from Earth. Give it a little more. Put that around the sun. And ends up around Mars. Now, because we're using the sun as the central body for all this, doesn't show it captured in Mars orbit, just shows it kind of being close to Mars and at a similar speed relative to the sun in general. But what we'll talk about next time is actually modeling Martian parking orbit and going from there to Mars's moons for the final mission.